Alright guys, for the rest of the semester, we're really going to be focusing on trig functions. But before we get into trig functions, we have to talk about triangles. The first thing I want to mention is that, do you guys remember how many degrees are in a triangle? Or what do the angles add up to? Always remember that the angle measure of a triangle adds up to 180 degrees. But we'll talk more about that in later videos. So there are different types of triangles out there. I listed some of them right here. We have equilateral, isosceles, scalene, right? So what are the differences? So equilateral triangles, well, all their sides have equal length. And because all the sides have equal length, that means each of their angle measures are also equal, right? So that 180 degrees that's in a triangle is split evenly amongst them. So there's 60 degrees in each of those corners. Isosceles triangle, well, that means they have two of the same sides. That means two of the angle measures are also the same. But what we're really focusing on in this class is the right triangle. And what's so special about a right triangle? Well, there's many things, but a right triangle, see this little box right here? It indicates that there's a 90-degree angle in our right triangle. There's a 90-degree angle in our right triangle. That means anytime you are given a right triangle, you automatically know what one of the angle measures is, and you're left with finding the other two. Okay, so a right triangle has many different parts. It has three sides, of course, and you should be able to just look at a right triangle and identify each side correctly. So the most important one here is this guy right here, the hypotenuse. The hypotenuse is always the longest side of the right triangle. So whether the triangle is faced this way, I don't know, like this way, this is a terrible triangle, I know, I'm sorry, this way or whatnot, your hypotenuse is always going to be the longest side of your right triangle. Let's see. Now, the other two sides, you have to focus on what angle your triangle is talking about. So see, in this picture, we're given angle theta. So my other two sides are going to be referencing this angle theta. Now, this side over here says is the side opposite of angle theta. Well, that makes sense, right? Because here, if angle theta is here, then opposite of it would be this side. So that 100% makes sense. Now, this side right here, this one is adjacent to angle theta. Now, of course, there are two adjacent sides to angle theta, but one of them is going to be the longest side, which is our hypotenuse. So we don't call him the adjacent, we call the leftover one the adjacent side. Okay, good. So hopefully a lot of this is review for many of you guys. You remember from high school or something like that. So the interesting thing about right triangles is there's some sort of correlation between the angle measure and the sides of the triangle. And they're defined through these things called trigonometric functions. So you guys remember all this? We have sine, cosine, all this fun stuff that you guys probably haven't seen for a while, but it's okay. Okay, so let's just talk about a couple of them. Let's talk about sine first, all right? If I take sine of an angle, theta, so if I take sine theta, this is equal to the opposite side of my triangle divided by the hypotenuse. So if this is my angle right here, theta, I'm going to take this guy's side, the opposite side, and I'm going to divide it by whatever the length of the hypotenuse is. And if I am talking about cosine, I'm going to set a ratio up between the adjacent side divided by the hypotenuse to compute cosine theta, sine theta. Now, we haven't really talked about what sine theta is or what cosine theta is, so we're taking it at face value right now. I just want you guys to remember these definitions that you probably used in high school. Okay, so let's just go down this list, right? So sine theta is equal to the opposite over the hypotenuse. Cosine theta is equal to the adjacent side divided by the hypotenuse. And tan theta is equal to the opposite side divided by the adjacent side. So we're just laying down definitions right now, definitions of what trigonometric functions look like. Okay, so on the right-hand side, you'll see a bunch of other things. See, we have CSC. These are less seen functions, but these are the reciprocal functions, meaning if I have sine here, 1 over sine is equal to this guy, cosecant. If I have cosine here and I do 1 over cosine, this is equal to secant. And if I take tangent and I put the reciprocal of tangent, then I'm given cotangent. So everything that you see on the right-hand side is the reciprocal function. So that means, what does the reciprocal mean? That means if you have a fraction, just flip it upside down, which makes sense because since sine is opposite over hypotenuse, if I flip it upside down, I'm going to have hypotenuse over opposite. And the same thing here, right? If I have adjacent over hypotenuse, if I flip it on its head, I get hypotenuse over adjacent. If I have adjacent over hypotenuse, then I get hypotenuse over adjacent. Then if I have opposite over adjacent, then I'm going to get adjacent over hypotenuse. So you guys see they're correlated, right? This guy is the reciprocal of sine, this guy is the reciprocal of cosine, this guy is the reciprocal of tangent. And they have, when I was in high school, which was a long time ago, they showed us this thing down here, and they pronounced it SOHCAHTOA. And I don't know why, I still remember it, and it might help you guys too. SOHCAHTOA was kind of an abbreviation for remembering these trig functions. So this S stands for sine, this C stands for cosine, and this T stands for tangent. And what they're saying is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's good to remember SOHCAHTOA. Like I said, it's been a long time since I've been in high school, and I still remember it, so it might help you guys out. All right, so let's get some practice with these trig functions, okay? Okay, so we're given a right triangle here, and our goal is to find all 6 trig functions. Okay, so let's first identify what's what. We know that the longest side right here, this is our longest side of our triangle, and it's going to be our hypotenuse. But which one is our adjacent and which ones are opposite? Well, if we're talking about theta here, the side opposite of theta would be 8. So this guy, 8, would be opposite, which leaves only 1 left for adjacent. This guy right here, 6, is the side that's adjacent to theta. Now notice how a triangle has 3 sides, but we're only given 2 of them. So guess what we got to do? We got to figure out what h is equal to. H has to be equal to some length, and we need a way to figure out what that length is. And this is why we work with right triangles for the most part, because we have a formula or a way of finding out the sides of a right triangle, and that's called the Pythagorean theorem. Do you guys remember that? A squared plus b squared equals c squared. So we're going to use a squared plus b squared equals c squared to figure out what the length of h is. And remember, whenever you're using Pythagorean theorem, c squared, this guy all by itself on the other side, is always the hypotenuse squared. C is the longest side of our right triangle. Okay, so let's go ahead. So we have a squared plus b squared equals c squared, but c squared is the hypotenuse squared, so I changed it to h squared. And a squared, well, it could be either one of these sides. I picked 6 to be a, and I just picked 8 to be b. It could have been the other way around. It really doesn't matter. And I had to square both of those sides and add them together to figure out what h squared is. So 6 squared is 36, and 8 squared is 64. So I have 36 plus 64 equals h squared. So I don't know why I wrote 36 plus, I should just turn that to 100. So 36 plus 64 is 100. And now what I have is, I have 100 equals h squared, but to get h by itself, I take the square root of both sides. So if I square root h squared, I'm just left with h. And if I take the square root of 100, I'm left with 10, right? So that means h is equal to 10. Not bad. So if you forgot your Pythagorean theorem, I highly recommend going back, looking up different YouTube videos or whatever, going back into your textbook and reviewing it, because we're not going to spend too much time on that in this class, but it's something you must know. Okay, so let's go through each of these trig functions and let's figure out what they're equal to. Okay, so let me just write over here. So h is 10. 8 is the opposite. Maybe I'll write it the other way around. Opposite is 8, and 6 is the adjacent. Okay, so remember, sine. Sine is equal to opposite over hypotenuse, right? Remember SOHCAHTOA. Opposite over hypotenuse. So my opposite length is 8, and my hypotenuse's length is 10. So I have 8 over 10. And they both can be reduced because they're both a multiple of 2. So I can reduce 8 over 10 to 4 over 5. Okay, cosine. Cosine is adjacent over hypotenuse. My adjacent side has length 6, and sometimes my computer does this, I don't know why. And my hypotenuse has length 10. So that means cosine theta is equal to 6 over 10. And I can reduce that again to 3 over 5. So tan theta is equal to opposite over adjacent. So the opposite side has length 8, and the adjacent side has length 6. Right? Has length 8, adjacent has length 6. So I have 8 over 6. I can reduce that down to 4 divided by 3. And if to find the other 3 trig functions, remember, they're the reciprocal. So to find out what cosecant is, I take sine and I just flip it on its head. So cosecant should equal 5 over 4. And secant should be 5 over 3, right? I'm just flipping them around. We already showed that they're the reciprocal. And that means cotangent should equal 3 over 4. So let's zoom out. So you see, we kept the relationship. Cosecant is the reciprocal of sine. So sine had 4 over 5, so then cosecant was 5 over 4. Cosine was 3 over 5, secant was 5 over 3. Tangent was 4 over 3, cotangent was 3 over 4. So we just flip them on their head. All right. So let's see, what do we got next? Given the following right triangle, find all 6 trig functions. Oh, so same thing again. Okay, so this time, what is our longest side? 3. So 3 is our hypotenuse. Theta is over here on this side of the triangle. So that means, what is the opposite side here? The side opposite of theta would be this guy, 1, right? Because if I draw an arrow right from theta, you'll land right here at 1. Which means that B is my adjacent side. Again, we don't know what B is, so we have to use the Pythagorean theorem to solve for B. So a squared plus b squared equals c squared. Remember, c is always the hypotenuse, so it's going to look a little different this time. On the left-hand side is my unknown this time. So I have 1 squared plus my unknown squared equaling the hypotenuse squared using the Pythagorean theorem. So that means I get 1 plus b squared equals 9, right? 3 squared is equal to 9, 1 squared is equal to 1. Okay, so now I'm going to subtract 1 from both sides. So I get b squared equals 8. Oh, why did I pick such ugly numbers? It's okay. Okay, if I take the square root of both sides, I get square root of 8. Now remember, normally when we take the square root of a square, we're usually left with plus or minus on the right-hand side, on the other side. But why don't we have plus or minus for these? Well, because we're talking about the length of something. And when we talk about length of something, I never have a negative length. Like I never say I'm negative 5 feet tall. It doesn't make sense, right? So whenever we talk about length, we always take the positive form of things. That's just a side note. So b is equal to square root of 8, but square root of 8 can be turned into square root of 4 times 2. I hope you guys remember how to do this. It's been a while, I know. So at this step, when I break 8 up into 4 times 2, I can split my radical into square root of 4 times square root of 2. But what is the square root of 4 equal to? That's just 2. And the square root of 2 is just square root of 2. So that's why our final answer here is 2 times square root of 2. So anytime you see a number inside your square root that can be broken apart like this into 2 different numbers where one is a perfect square, I would go ahead and do it and make your life easier. Okay, so let's apply SOHCAHTOA again to find these trig functions. Let me just rewrite those numbers actually. So the hypotenuse, 3 was the hypotenuse, and we found the adjacent side was 2 times square root of 2, and the opposite side was 1. Okay, so using SOHCAHTOA, sine of theta is equal to opposite over hypotenuse. So I take the opposite, the length of the opposite divided by the length of the hypotenuse. So I have 1 over 3. Hopefully you guys are seeing a pattern here. For cosine, it's adjacent over hypotenuse. So I take the length of the adjacent side. Adjacent side is what we just found out, which is 2 times square root of 2, and I divide it by the length of the hypotenuse, which is 3. Lastly, we have tangent, which is the length of the side opposite of theta, so that's 1. And then we have the length of the side adjacent to theta, which is 2 times square root of 2. So right here. And now to find the other 3 trig functions, we just take the reciprocal of this, right? We flip it all of these guys on its head. Boom. So sine theta goes to cosecant, cosine goes to secant, and tangent goes to cotangent. And all of these guys just become the reciprocal. I just flip it on its head. Boom, and boom. Good. So I hope you guys are getting this. If you guys ever have any questions, remember, always just email me. Alrighty. So one thing you'll notice is in your homework, in your homework or your textbook, things like that, it's not good enough to leave your answer like with some sort of square root on the bottom. You see how we have like a square root right here in the denominator? Your online homework or your textbook, they won't always accept that as an answer. So what you have to do is you have to rationalize the denominator, meaning get rid of all the square roots in any denominator. So let's go ahead and rationalize this guy. Tan theta equals 1 over 2 times square root of 2. So in order to rationalize the denominator, all I'm going to do is I'm going to multiply the numerator and denominator by whatever is in the denominator. So I'm going to multiply this whole guy by whatever's in the denominator, top and bottom. So it's going to look like this. I have tan theta equals 1 divided by 2 times square root of 2 times whatever was in the denominator divided by whatever was in the denominator. Now, why do we do it to the numerator and denominator? Because what is 2 times square root of 2 divided by 2 square root of 2? Well, it's just 1. So in a sense, what this thing is saying is take tan theta take 1 over 2 times square root of 2 and multiply it by 1. And if you just multiply by 1, you're not going to change the value of the actual number. So when we multiply by 1, we don't change the actual value, but we are able to rationalize the denominator. When you multiply fractions, just multiply the numerators, and then you're just going to multiply the denominators in the bottom. So if I multiply the two numerators, I get 1 times 2 times square root of 2. And if I multiply the denominator, let's see what I get. I get 8. Now, how did I get 8? Well, let's come over here to my side note. Well, if I multiply the two denominators, I get 2 times, computer freaks out, 2 times square root of 2 times 2 times square root of 2. So another way to express this is that I have 2 times square root of 2 squared. Right, so because I have the same thing multiplied to itself, that means it's that thing squared. Whenever you square some sort of product, I can take this square and I can put it to each individual component. So I can take 2 squared, which is what I did here, and then I did square root of 2 squared, which is what I did right here. So what is 2 squared? 2 squared is 4, but square root of 2 squared is just 2. So I have 4 times 2, which equals 8. If that seems a little confusing to you guys, I recommend looking up exercises. They probably make you do it on your homework anyway. But that's an important skill to know, especially for your homework and textbook purposes. All right, so in the numerator, if I multiply the numerators, I get 2 times square root of 2, and in the denominator, I get 8. And I can simplify, and I get square root of 2 over 4. Okay, let's do one more. So here I have sine theta equals 1 over square root of 3. I want to rationalize the denominator. So what I'm going to do is I'm going to multiply the numerator and denominator by my current denominator. So I have sine theta equals 1 divided by square root of 3 times square root of 3 over square root of 3. And I can do this because square root of 3 divided by square root of 3 is equal to 1. So I'm not changing the value, I'm just multiplying by 1. When I multiply fractions, I first multiply the numerator to get my new numerator, and then I multiply my two denominators to get my new denominator. So if I multiply my two numerators, I have 1 times square root of 3, which is square root of 3, and in the denominator I have square root of 3 times square root of 3. Square root of 3 times square root of 3 is also known as square root of 3 squared. So we know that is infamously 3. So I have my final answer is square root of 3 over 3. Alrighty. So last thing before we end this section. Oh, maybe not. I forgot we have a couple more. I guess it's a long lecture. I apologize, guys. I try my best to make short lectures, but it doesn't always work out this way. So we can always figure out, using the trig functions, we can figure out what sine theta is equal to cosine theta, tan theta, using opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. But there are a couple of reoccurring angles that always pop up. They're probably going to ask you what sine of 30 degrees will equal, or what sine of 45 degrees is going to equal, or sine of 60 degrees will equal. And they'll also give you these things called radians, which we'll talk about in a couple of videos. So this row right here is saying this: sine of 30 degrees is equal to 1 over 2. Sine of 45 degrees is equal to square root of 2 over 2. Sine of 60 degrees is square root of 3 over 2. And in the following rows, they do the same thing with cosine and tangent. So cosine of 30 degrees is equal to square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2, and so on and so forth. So these numbers really come from common right triangles that occur. So, and these are, make sure I have the right pen out. So this is the two triangles that they come from is when your right triangle has obviously a 90 degree, 60 degree, and 30 degree. And the other one is where I have 90 degree and two 45 degree angles. But we're more concerned about how to apply this. So here's our first example. So I'm given a right triangle where I know that one angle is 45 degrees. The adjacent side has a length of 250, and they want me to solve for A. So A, relative to this angle, is the opposite side. This is the longest side of my triangle, so this will be the hypotenuse. And this guy is my adjacent side because he's next to my angle and not the hypotenuse. So what do they want me to solve? They want me to solve for the opposite side, but they've given me the adjacent side. So they've given me opposite and adjacent. Because we're talking about opposite and adjacent, I'm going to use tangent. See, there in tangent, I use opposite and adjacent. Since I don't know what the hypotenuse is, or they're not asking for the hypotenuse, I'm not going to use cosine or sine, which have hypotenuses in their definition. So because of this, I'm going to use tan theta as my reference here. And let me try to highlight it. Come on, there it is. So to figure out what A is, I'm going to use tan theta equals the opposite over hypotenuse. And I'm just going to fill in some stuff. We know what theta is in this example. Theta is the angle measure, which is 45 degrees. The opposite side length is what we're trying to figure out. So that's just A. And the adjacent side length is 250. So our goal is to figure out what A is equal to. Well, this is okay. Why? because we know what tan of 45 degrees is. How do we know that? Well, we have a chart right here. Look, tan of 45 degrees is equal to 1. All right, so that means I can replace this tan 45 with 1. So copy. So that means 1, tan 45 is equal to 1, and I have equals A divided by 250. So how do I solve for A? I multiply both sides by 250. So my resulting answer is just A equals little a equals 250. So if I multiply both sides by 250, 250, and 250, these 250s cancel out, and I have 1 times 250 on the left-hand side, which is just 250. Awesome. So let's do one more before we have one last word problem. Geez, guys, I'm sorry. All right, so, I mean, the great thing about YouTube videos is you can literally just fast forward through a lot of this if you understand it. Okay, so here they're giving us an angle measure, and they want to know what B is. Relative to this angle, this side, B, is opposite. So B is our opposite side. And this guy, well, he's not the longest side, so he must be the adjacent side. Again, they want us to deal with opposite and adjacent values. So because they don't talk about hypotenuse, we're not going to use sine, nor will we use cosine, but we will use tan theta. Boom. We will use tangent. Okay, good. So we know what come on, work. We know what our angle measure is here. It's 60. And what do we know? We also know what the adjacent angle is. Adjacent side length is. It's 10. What we don't know is what the opposite side length is. So how do we solve for the opposite side? Well, we know what tan of 60 degrees is. How do we know? Well, we have it in our chart. Tangent of 60 degrees is equal to square root of 3. So I can replace tan of 60 degrees with square root of 3 and set it equal to my left-hand side. So how do I solve for the opposite side length? Well, just like before, I multiply both sides by 10. These two 10s will cancel out, and I'm just left with 10 times square root of 3 equals B. Sorry, I don't know why I left it as O. All of these should be B, right? Because that was what they labeled it as. Okay, last one. We're doing good. At a certain time of day, the angular elevation of the sun is 30 degrees. To the nearest foot, find the height of a tree whose shadow is 35 feet long. So I drew a little picture. It's pretty good. I know I'm talented. All right, so these little yellow things that I drew, they're like rays from the sun. This is our tree. And this is this gray part right here. That's the shadow. And the length of that shadow is 35 feet. And if I'm down here and I look at the top of the tree, it's a 30-degree incline. So this angle right here is 30 degrees. And what they want us to know is what is the height of the tree. Well, if I take a step back, instead of looking at this beautiful picture that I painted for you with shadows and sun rays, we can really simplify this thing down to a right triangle, right? This picture is actually this picture, where X is the height of the tree, 35 is the base or the shadow, and 30 degrees is the height or the angle measure when I'm looking up to the top of the tree. So notice how this picture on the left is similar to this picture on the right. And what they want us to do is they want us to find out what x is equal to. Well, x, relative to this angle that they gave us, is on the side opposite. And the shadow is on the adjacent side. So guess what we're doing again, guys? How do we solve for x? We can't use sine. We can't use cosine because they didn't give us the hypotenuse. So again, maybe I should have been more dynamic with my examples. But again, we're going to be using tangent, if I can make tangent work right now. Copy. Paste. Of course. All right, I completely lost us. I think we're over here. Wow, I don't know why that happened. I'll just write it out. All right, so we have tan theta equals opposite over adjacent. But we know what theta is, right? We have tan of 30 degrees. Opposite is equal to x, and adjacent length is 35. So how do we solve for x? Well, before we even multiply, we know what tan 30 is. Tan of 30 degrees, tangent of 30 degrees is square root of 3 over 3. So I come back down here, square root of 3. My computer's breaking. So square root of 3 over 3 is equal to x divided by 35. How do I solve for x? I multiply both sides by 35. When I multiply both sides by 35, these guys cancel out. So that's my answer right there. And that's some number that I can't calculate in my head. I'm sorry. All right, guys. So I'm sorry that was a long video, but hopefully you guys got the gist of using the trig functions. All right, the next one will be shorter, I promise.